Alright, so we're looking at the fourth set of FRQ practice problems. Let's start with problem number one. Problem number one gives you two modeling equations. One is a rate of fish entering a lake, and the other is the rate of the fish leaving. The entering equation is the E equation, the leaving equation is the L equation. The first one asks how many fish enter over a 5-hour period from t equals 0 to t equals 5. Give the number as a whole number. This is just an accumulation problem, so you're going to take 0 to 5 of the entering equation at times t dt. When you put that thing into the calculator, it comes out as approximately 153.457. So to the nearest whole number, this is 153 fish. Looking at part B of the problem, what is the average number of fish that leave the lake per hour over a 5-hour period? So we want to know, so the leaving equation is the rate of leaving, right? So this is, we want the average rate. So this is the average number of fish that leave per hour. So it's just 1 over 5 minus 0 times 0 to 5 of the leaving equation, dt, which is 1/5 of 0 to 5 of the leaving equation, dt, which works out to be approximately 6.059 fish per hour on average. Alright, so part C is interesting here. The rate, so it's at what point are the greatest number of fish in the lake, right? At what point in time are the greatest number of fish in the lake? Alright, so if you think about this, the number of fish in the lake is going to be the accumulation at time k. It will be the accumulation given by the E equation minus the accumulation given by the L equation plus some constant, right? So I want to optimize this, right? I'm trying to maximize that value. So I want to know, when is f prime of k? Well, f prime of k is going to be just e, by the fundamental theory of calculus, it's going to be e of k minus L of k. And this is going to be on the interval 0 to 8. Alright, so if you do graph this out, you find that f prime of k is equal to 0 when k is equal to 6.203564. Well, but see, when you look at that graph a little bit further, you find that f prime of k is less than 0 on the interval from 0 to k, and f prime of k is greater than 0 on the interval from k to 8, which means that if I'm, sorry, I've got that backwards. This one is greater than, this one is less than, right? So I'm increasing till I get to k, and then decreasing from k over the entire interval. So these two facts lead that f has absolute max at k, which means the greatest number of fish in lake happens when t is this k value, 6.203. So there you have it. So that's the value of t when you have the greatest number of fish in the lake. All right, so let's look at part D of the problem. Part D of the problem is the rate of change in the number of fish increasing or decreasing? So this is the second derivative of f. So we want the derivative with respect to t of f prime of t, because that's the rate of increase or decrease of the fish. And we want this at time t5. So this is the derivative with respect to t of the E equation minus the L equation at times t equals 5, which means this happens at approximately negative 10.722. That's the value of the second derivative. The second derivative is less than 0, which means that the rate of change is decreasing. So the second derivative is the rate of change increasing or decreasing? Second derivative is negative, so the rate of change is in fact decreasing. Right. So problem number 2, they give us a function with a whole bunch of data. They say that the function is defined at negative 6 to 5, but we only get the graph from negative 2 to 5. We're told that there's a quarter circle in this graph, and it's known that the point 3 minus radical 5 is on the graph. All right, so they tell me that the integral from negative 6 to 5 is 7. We want the value of the unseen part of the graph. So the negative 6 to negative 2. So the following statement is true. Negative 6 to 5, f of x dx is equal to negative 6 to negative 2, f of x dx plus the integral from negative 2 to 5 of f of x dx. Okay, so this is 7. This is what we're looking for. And then this last part is, well, there's a triangle. Reading this from left to right, there's a triangle above the graph that is base 1, height 1. And then there's a triangle below the graph, base 1, height 1. And then you've got a triangle above the graph, base a half. Sorry, below the graph, base a half, height 1. You have a triangle above the graph, base 3 halves with height 3. And then you get this, like, the shadow of the circle. So if you kind of imagine that there's a 3 by 3 grid there, that whole area would be 9. If I take away the quarter circle with a radius 3, that's going to be 9 pi over 4. And we can kind of math on this a little bit, right? Because that's going to cancel with that. Let's see what we get here. 7 is the integral from negative 6 to negative 2, f of x dx. This is a fourth, negative, plus 9/4 plus 9 minus 9 pi over 4. So this is negative 6 to negative 2, f of x dx would be 11 plus minus 9 pi over 4. So this means the integral from negative 6 to negative 2, f of x dx. So this should be a plus here, right? There we go. Should be equal to 9 pi over 4 minus 4. Right. So there you go. That's that problem. Let's look at part B. Okay, so part B gives us another integral. It says evaluate the integral from 3 to 5 of 2 f prime of x plus 4 dx. So what I did is I broke this apart. I made it 2 times the integral from 3 to 5 of f prime of x dx plus the integral from 3 to 5 of 4 dx. Well, fundamental theorem of calculus here says this is f of 5 minus f of 3. And this is width of 2, height of 4. So that's just going to be 8. F of 5 is 0. F of 3 is given in the problem as 3 minus the square root of 5 plus 8. So this gets me 6 minus negative 6 plus 2 times the square root of 5 plus 8, which means that I have 2 radical 5 plus 2. And that's the end of that problem. Alright, so let's look at part C. Part C says g is the integral function starting at negative 2. Find the absolute minimum of g. Alright, so g prime of x is going to be f of x. So I have to look at where f of x is 0. F of x is 0 when, so g prime of x equals 0 when x is negative 1, 1/2, and 5. So my critical points are going to be negative 2, negative 1, 1/2, and 5. G of negative 2 is pretty obvious. That's 0. Because that's from negative 2 to negative 2. So that's going to give me 0. G of negative 1, it just involves that one triangle. So that's half base of 1, height of 1. It's g of negative 1 is a half. G of 1/2 is going to take that 1/2 and it's now going to subtract 1 base of 3/2 height of 1. So this is a half minus 3/4, which is negative 1/4. Right, so g of 5 takes that negative 1/4. It now adds a triangle, which is half times 3/2 times 3. And then it adds this half circle thing again. So that's 9 minus 9 pi over 4. So this is negative 1/4 plus 9/4. What did I miss? Oh no, plus 9, which would be 36/4. No, I don't need to do that. Let's just make that 9. 9 minus 9 pi over 4. This is 8 over 4, which is 2, plus 9 is 11 minus 9 pi over 4. So there you go. That's the max, because that one is bigger than all of these. So max value. Alright, so let's look at part D. So when this thing was put on the BC exam, this was probably a way for you to get that 9th point, and they hid it in the last part, because this is the limit as x approaches 1 of 10 to the x minus 3 f prime of x over f of x minus the arctangent of x. Literally, this is a substitute in. So this is 10 to the first minus 3 and f prime of 1. Well, if you take a look at that, that thing's going up 2 over 1, so that just makes it slope 2. F of 1 is just 1 minus the arctangent of 1. So this becomes 10 minus 6 is 4, 1 minus pi over 4. And that's it. That's the whole problem. It's substitute and simplify. All right, problem number 3 here is they're giving me a cylinder. Note that the radius of the cylinder is 1. That's a constant. They give me a rate of change for the height in terms of height, not time. That's important. So let's take a look at the first question. The first question is find the rate of change of the volume with respect to time when the height of the water is 4. Indicate the unit of measurement. So volume is equal to pi r squared h. But in this case, the radius is 1, so it's just pi h. So dv dt is going to be pi dh dt. We know that dh dt, according to this problem, is negative 1/10 times the square root of the height, which we're told is 4. So dv dt is going to be negative 1/5, negative pi over 5. And this is cubic feet per second is the rate at which the volume is changing when the height is 4. All right, so let's look for part B of the problem. Part B of the problem says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So this is a second derivative. All right. All right, so we know that dh dt is negative 1/10 h to the 1/2, which means the second derivative of height with respect to time is going to be negative 1/20 h to the negative 1/2 dh dt, which is negative 120 times the square root of h, 120 over, that's a negative 1/2. So let's fix that. That's going to be negative 20 square root of h times dh dt, which is negative square root of h over 10. Okay, so h here is, now we're going to sub it at 3. So this is negative 120 times the square root of 3 minus the square root of 3 over 10. The 2 square roots of 3 cancel, so this is 1/200, which is bigger than 0, which means the rate of change is increasing. Okay. All right, so let's look at part C. Time 0 seconds, which is the height of the water, is 5 feet. Use separation of variables in order to, so this is given the differential equation, dh dt is negative h to the 1/2 over 10. We want to find this whole thing, h in terms of t. So we get h to the negative 1/2 dh is going to be negative 1/10 dt. Take the integral of both sides. So this is going to become 2h to the 1/2 is now negative 1/10 negative t over 10 plus some constant. All right, so if we throw in that the height is 5 when the t is 0, that means that c has to be 2 radical 5. Okay, so 2 times the square root of h is equal to negative t over 10 plus 2 times the square root of 5. Divide it all by 2, you get the square root of h is negative t over 20 plus the square root of 5. Square both sides. H of t should be negative t over 20 plus the square root of 5 squared. So there is height in terms of time. Alright, so let's look at the next one. Alright, so we have the function f of x is equal to 1 over x squared minus 2x plus k. We want to know what value of k does the slope of the tangent line of the graph at x equals 0 equals 6. Okay, so I'm given that f of x is 1 over x squared minus 2x plus k. I think I'm going to do it this way. Let's make this equal to x squared minus 2x plus k to the negative 1, which means f prime of x is going to be negative x squared minus 2x plus k times to the negative 2 times 2x minus 2. So another way of writing that is to say it's 2. So if I bring that negative into this, it's going to give me 2 minus 2x over x squared minus 2x plus k squared. I think I did that using the quotient rule in the problem set, but you can also do it this way using the chain rule. So I'm going to let x equal 0 and let f prime of x equals 6. This is going to be 2 over k squared, which means that k squared is a third, which means k is 1 over the square root of 3. Alright, so there's part A of the problem. Let's look at part B. Okay, so part B says let k be negative 8 and find the integral from 0 to 1 of this. So we're going to say that this is x squared minus 2x minus 8 dx. This is begging to be factored. So this is going to give me x minus 4, x plus 2, which means that this is now one of these this is a partial fractions problem, right? So 1 over x minus 4 times x plus 2 is a over x minus 4 plus b over x minus 2, which means that 1 is a times x minus 2 plus b times x minus 4. So this is going to give me a plus b times x minus 2a minus 4b, right? So that tells me that a plus b has to equal 0, and negative 2a minus 4b has to equal 1. So that means 2a plus 2b is 0. Negative 2a minus 4b is equal to 1. Okay. So, oh, no. Wait. There's the mistake. This is x plus 2 plus 2 plus 2. Alright, so let's back this up a minute. Alright, fix this. This is plus 2, plus 2, plus 2, plus 2. So I don't want to multiply this by 2, I want to multiply by negative 2a minus 2b is 0. There we go. 2a minus 4b is 1. Those fall out, gives me negative 6b is equal to 1, which means b is negative 1/6, which in turn is going to mean that a is a 1/6. Alright, so this now becomes integral from 0 to 1 of 1/6 times 1 over x minus 4 minus 1/6 times 1 over x plus 2 dx. When I take the integral here, I'm going to get 1/6 times the natural log of x minus 4 minus 1/6 times the natural log of x plus 2 from 0 to 1. Put the 1's in there, and I get 1/6 times the natural log of 3 minus 1/6 times the natural log of 3 plus 1, sorry, so that's the front one, minus 1/6 times the natural log of 4 minus 1/6 times the natural log of 2. So these cancel. Makes this negative 1/6 times the natural log of 4 plus 1/6 times the natural log of 2, which would be negative 2/6 times the natural log of 2 plus 1/6 times the natural log of 2, which gives me negative 1/6 times the natural log of 2. I think it's as simple as I can get it. But in actuality, if you like stop here probably, I think you're good. You probably can actually stop one line up from there and be considered having a correct answer for the sake of the BC exam, but this is about as simplified as you can go with that problem. Okay, so let's look at part C of this problem. We have the integral from 0 to 2 of f of x dx, which is the integral from 0 to 2. And now we're going to substitute 1 for k here, so that's going to give me 1 over x squared minus 2x plus 1 dx. That's we call it a binomial square. So this is actually going to be x minus 1 squared dx. Now the problem here is that 1 is in the interval. Okay, so you get an improper integral here. So we have to take the limit as a approaches 1 from the left of the integral from 0 to a of 1 over x minus 1 squared dx. I think it's easier if I write this as x minus 1 to the negative 2 dx plus the limit as b approaches 1 from the right of b to 2 of x minus 1 to the negative 2 dx. So this becomes the limit as a approaches 1, negative 1 of 1 over negative 1 over x minus 1 from 0 to a, which is the limit as b approaches 1 of negative 1 over x minus 1 from b to 2. So this is the limit as a approaches from the negative side of negative 1 a minus 1 plus 1 plus the limit as b approaches 1 from the positive side of negative 1 minus, so that's going to be plus 1 over b minus 1. Note the limit as a approaches 1 from the negative side of negative 1 over a minus 1 does not exist, which means that this thing diverges. Okay, and you can see it here as well. It's going to diverge in both cases. Alright, so that one just doesn't exist. Alright, so there's the entire problem set. Hope you've had fun. Again, bring questions to the drop-in, or ask questions, via email, whatever you need. Hopefully this is helping. Hope to hear from you soon.